You are welcome my lecture. Today I will do the one lecture of course unit of mathematics for business, and our topic is calculus. So under the calculus there are three different sections or parts. Among them today I will discuss you the first branch of the calculus, that is limits. First, learning outcomes of this session. So after the completion of this session, you should be able to understand or explain the definition of limits and estimate the limits, and you should be able to determine whether limits of functions exist or not, and also you can use properties of limit and direct substitution to evaluate limits. And finally, right, if we have time, right? So this final learning outcomes, right? So depend on the depend on the time if we have to discuss these two, right? Otherwise, I will do it in next session. Anyway, if we have time, I will discuss how to define the the basic theories under the differentiation. And also I hope to discuss with you basic rules of differentiation and how to evaluate those some functions, how to evaluate simple functions by using basic differentiation rule, right? So anyway, first I will focus the first three learning outcomes, right? Okay. Anyway, this is limits, right? Our topic is limits. It also comes under the calculus main topic. That is, the calculus is main topic, and the one branch of calculus is limits. So anyway, I would like to explain, right? What is this calculus? So through the calculus. So by using the calculus, we can represent the functions. We can represent the changes between values of a function. And so the up to now, you know, we have understood the different type of functions, right? So among them, we can now, you know, I will show you, right? This is also the function, right? So function, Sritaya, but it is a straight line, right? A straight line. And that means its slope is every point on the line, on the function, slope is equal, right? And then this is the simple linear function. And also, you know, when we draw in the sum function, its shape is this line, right? Parabola shape. That means that function is quadratic function. That means the quadratic functions as the squared term with some coefficient, right? And other terms, that means the x term or constant term likes, right? So, but same time, if it is the quadratic function, right, based on quadratic terms, that means the square terms sign negative or positive, then we know we have a maximum value or negative, maximum vertex or minimum vertex, right? That means quadratic functions square terms, coefficient is minus, that means we have a maximum, right, vertex. Okay? Otherwise, is opposite of that one, we can get the minimum vertex. And not only that, right? So our functions also can be with the cubic value, right? With the coefficient or coefficient 1 or more coefficient, and also power to 4, right? Power to 5th, likewise, right? So then, if our functions has this kind of terms, that means with the high power, unknown variables power is greater than 2, then its shape is different, right? So sometimes its shape is this way, right? This way, we don't know, right? So based on the terms power and terms other values, it's depend. Okay. So, but now up to now, we know how to identify the slope of this straight line. But then our problem is how we can identify the slope of this different shapes functions. And just we know in the when we considering only one, right? That means when we considering this one, you can see in this curve, in the different point, slope is different. Here slope is this way, right? That's but in here slope like this, right? In here what? So very high slope, right? Likewise, okay. So slope is different and different points in the same function. So therefore, when we if we want to find out this slope of the different functions, different point, then we can use this calculus, right? Calculus. So therefore, that means generally we can say when explaining or identifying non-linear type functions, right? Non-linear type functions behavior, then we have or we need to or we can use calculus. We can use calculus. That's why it is important and we are learning. So then now I move to the limits, right? So to do the introduction of limits, I would like to explain you this example. I think through this example, you can very clearly understand the meaning of limits, right? Meaning of limit. So therefore, and so this is the section of the scenario. Just let x represent the width of the rectangle and let xl represent the length of the rectangle. So you know the shape of the rectangle, right? Rectangle, the shape is this one, right? And also if it is squared, also we know that it is also rectangle, right? Rectangle can be any shape, but the thing is any rectangles opposite side opposite sides are equal, right? Opposite sides are equal. So then my question is, right? If L represent the width of the rectangle, right? So I can't. Something that's happening here. Yes, it's not okay, no? Yeah, W represent the width of the rectangle, and if the L is representing the other side, length or maybe both, right? Maybe W is the width and L because here shape is a little bit different, so that is better if I put in W here and L here, no? Length is the more, I don't anyway, right? So, and then therefore, you know the perimeter, right? Perimeter of this rectangle equal to, when we add in 4 sides length with 2 widths and 2 L's, right? So then our scenario says we have the rectangle with 24 inches 24 inches per meter. And so then the question with our problem is, if the per meter equal to this amount, 24, then what is that rectangle can take the maximum area? Maximum area, because it can be defined only because if 1W and yes, with the 1W and 1 well, it can be when we can get the area when multiplying these two. If our side this, okay, that means L is this way and W is very small, then we get another area. Right? So then it's asking what is the maximum area that equal to the 24 per meter. Okay. So then if we put in here W, right, then we know other side we can L side we can rename or we can represent how 12 minus W. Why? Because we know this for two sides are also 2 sides per meter equal to the other 2 sides per meter. Right? That means when we add in this one and this one, these 2 sides length is equal to these 2 sides. Then we know half of that one, half of the 24, that is 12 per meter, right? 12 inches is equal to W plus L. And also, right, W plus L. And also we can write, okay, then I'll show you, right? If this is L, oh, I'll put other side, okay? This is L, this is W. So then if this is W, then this L equal to 12 minus W. Is it okay? Because 2 sides equal to 12. Then we deduct in the W from the 12. Then remaining number equal to this side's length. Okay. So then we know the L also with the variable of Y, W. Okay. So then our question is area. Right. We know the for the rectangular area equal to length multiplied by width. Okay. In this case, we can write L multiplied by W. Okay. That's right. And also now we know our W, and also we can write L with using the W. Right. So therefore, we can write instead of this L, 12 minus W. Right. This 12 minus W. And next W, this one. Right. Therefore, finally, we can say our area equal to 12 minus W multiplied by W, right? So, we took this one, right? We have taken this one, right? And then area is this one. Or we can simplify this one when multiplying W, area equal to 12W minus W is square. This is the formula for area if our rectangle like this, okay, W in here, 12 minus W, right? 12 minus W. Then we know the area mean multiplied by these two sides, right? And then you can see in here, now we want to identify the rectangle which has the per meter equal to 24, and also it should have a highest, okay, maximum area when comparing the other rectangle that is also per meter equal to the same length. Okay, so therefore in here just we assume if our with W equal to 5, right? So then area, when we calculate in area, what is area? 35. You know, we need to substitute here W, right? W, if W equal to 5, 5 is when we square in 5, it's become 25. 12 multiplied by 5, 60, no? 60 minus 25 equal to 35, right? So likewise, we can calculate all the or compute area for the different type, different values for the our variable, that is W. If W equal to 5.5, then our area equal to this one. If W equal to 5.9, our area equal to this one. What we have to do? We need to apply this value in our identified equation, right? Equation, area, equation for the area. When we apply in 6, then its value become, area become this 36, right? And when we apply in 6.1 for the W, then it become 35.99, right? And also when we apply in the 6.5 for our W, then our total area become this one. So you can see then from here, from when we start in W equal to 5, and then area is become greater when we apply in the greater value, and it's become the 6, the value area is 6. And after that, right, again when we apply in the W for the W another more higher values, but our area become less, right? So then when we I have join this one, now you can see highest area we can get if our W equal to 6, right? That means, however, it's become, because not the rectangle shape, it is the square, but we know square also the rectangle. Okay, that means both sides equal to 6. Square equal to, also this is the rectangle, right? Square but rectangle also. So then the thing is in here, I want to explain you according to the limit terminology. We can now understand when our independent variables value move to the different value, the equation or function will get different value. So therefore, this one we can again explain, right? In this case, right? In this case, we can explain the limit of A approach to 6, right? The limits of A approach to 6 is 36, right? The limits of A as W approach 6, the value is 36. And also we can write it as the notation limit W move to 6, then area of the given function equal to this value 36. So that's the way how we can apply this limit approach, right? So that means when we move into the independent variables value in particular value, then what will happen? No, what is the value of our function? Just we know when we apply this particular value, right, in our function, we can get this one. But it is different because I will explain later, because sometimes when we apply some values in our function, we can't get the value, but we know there is a value, but we can't get value. That's why we say then there is when we just only the substitute in the independent variables value, we cannot get the always we cannot get the function's value. Okay, so that's why we say when move into the particular value to the particular value, right? Move into the particular value to the move into the independent variables value to the particular value, then functions get the some value. So therefore, we can define very correctly these limits, right? This way, right? Because we explain, we describe the any kind of the non-linear functions behavior by using this limit. So we can say limit are used to describe the behavior of a function as the independent variable move towards a certain value. When independent variables value reach into the certain value, then what is the, at that time, what is the behavior of the particular function? So this one we can represent with this notation. It's the general form. When x move to the a, fx functions limits, right? Move to the limit of the limit. When x move to the a, limit of the fx function is L. So, or you can say the limit of fx function as x approach the value a, it's equal to the L. And then the same thing, right? So now look at this one. So just very simply, right? Very simply, we can, or clearly you can understand limit of a function by looking at it graphically, right? What has happened in graphically. So then just assume our function is this one. Our function is limit of 2x minus 1 function. Then we have to find out when our independent variable, that is x, move into 2, what is our function's value. Right? Let's see. But here you can't see the animation. No, that's the problem. Otherwise you can see, because I have given here the graph with the animation, right? Anyway, I'll explain, right? In here you can see this. Here I use this straight line, right? No worry about that, right? This is our function, right? So then when x move to the 2, then x can be moved to the 2 from this side. When coming from this side, that means the positive side. And also x can move to the other side from the left side, right? So however x can move to the 2, then what is the our function's dependent variable value? This one, right? This one, you can see I have colored in here, right? So that means it appears as x coordinate get closer and closer to 2, y coordinates gets closer and closer to 3, right? So but why I explain this one? Shall I take another color, right? So then you can see when this x move to the this way, right? Before 2, right? Reaching to the before 2, then also y in here, right? If x come here and then when x stop here, then that is the y value also, right? This is the y value also, not this one, right? So then x reach to more closer to the 2, then y comes here, and also the other side x more reach to the 2, then here the x value, right? So likewise, when we a little bit reach into 2x, right, then y become 3, right? y එකත් මේ පැත්තේ ඉඳලා ටික ඉස්සරහට එන්නේ, එක්ක මේ පැත්තේ ඉඳලා ටික ඇවිල්ලා අවසානයේ තමයි මෙතෙන්ට එන්නේ 2 වලට ආවම, x 2 වලට ආවම y 3 වලට එනවා, right? So we can say that the limit of this function then equal to 3, okay? So then limit is a value of function, fx function approaches as the variable within that function gets near and near, close and close to a particular value, that is x. So when I move to the next one, so same thing, right? So you can, I will further explain. You can see then our function is 2x minus 1. So then I apply in here so assuming x equal to 1, so then also y gets the 1. Okay, you can see when I apply the 1 in here, 2 minus 1, 1. And when I apply the 1.5 as instead of x, then our y get the 3. When I apply the 2, then our y get the 3 likewise. Okay. So then when our x reach to the increase in here for this particular function, our y also get in higher value. Okay, you can see it. So then it's very clear if it appears as a x coordinates get closer and closer to 2, the y coordinates gets closer and closer to 3. So then after that we can say that the limit of this function is 3. Then remember, a limit is a value of function, fx function. Fx approaches as the variable within that function gets near and near to the particular value x, right? So that is the meaning of this limit, and through that we can explain the behavior of the functions, right? So then now you can see, right? So I'll explain moreover. So this is also the function, right? The given function is x squared minus 9 divided by x minus 3. This is function, but it with the portion, no? අපිට කියන බෙදීමක් ලබ්ධියක් එක්ක තියෙන දෙයක් function එක. හරි. So I don't know, we don't know the shape of it still, it's right, but we can draw it, right? When after drawing we can understand the slope of that shape of that function, but it's still, right, we don't know that. So then just think, if we want to find out these functions value when its independent variable, that is x, move into 3, right? So then we can get how, just we can apply it's the 3, right? Without applying others, just we can apply 3, x equal to 3 in this function. Okay. So now look at, when I apply in here 3 squared minus 9, and here 3 instead of x 3, and is a 3 also function. Then when we simplify, what has happened? Here this value is 9 minus 9, 3 minus 3. Okay. So this upside also the 0, right? At downside also the 0. Okay. Numerator and denominator both are 0. Then we can't define that one. We can undefine or we say it's moved to the infinite number. අනන්තයට යනවා කියලා අපි කියනවා. So that means what? So we can't understand that. We can't understand because this when x equal to 3, this function has no value, right? But it has value. But it has value. That one is defined or explain the limit, right? That one has explained the limit. Why? Just we consider if our x equal to 2, not the 3, 2, right? So then we can apply 2 in our function and we can get this value. You can do it by yourself and you can confirm that, okay? ඔගලන්ට තියෙන්නේ දෙක ආදේශ කළ සමීකරණේ පහ එනවද බලන එක විතරයි. Okay? It's okay, right? So just I'll do that. When we apply here 2, it becomes 4 minus 9 and 2 minus 3. That means 5 minus 5 divided by minus 1, that means plus 5. Okay, so right, it's very clear. And likewise, when you apply next, right, when we apply next 2.5 as its value in the function, then you can get function's value dependent value 5.5. When you apply 2.9 instead of x in the same function, you can get 5.9. But we did this one, it become no value, right? So that means no meaning in here. But when I apply, right, when I substitute 3.1 in the same function, we can get 6.1. You can check, right? And also if x equal to 3.5, then function value become this value. Okay. But the thing is here what? Right? The function does not approach a limit as x approach 3. Right? So because even though the function is not defined at x equal to 3. But, right? But when I consider in here same function. This is also the same function, right? So you can see same function, and I can write this function, right? X squared 9 by using our factorization knowledge. Same function, right? This same function we can write with the factors, right? X minus 3, x plus 3, right? So and also x minus 3 is the other one, right? Denominator and numerator are the same. So now you can see in here, in between these two brackets, we know it's multiplication, right? Product multiplication. That means we can cancel one whole bracket with the other bracket. Okay. When we simplify that, all right? When we simplify, what we'll do, we can do that way, right? So finally, its remaining part is this one, but same function. Oh, now we can apply our x equal to 3 in here, right? Now when x equal to 3, so we got the value. Now we can check 6, okay? The value we got is 6. Now you can see in here, okay? In here, if the x equal to 2.9, it becomes 5.9. 3.1, it becomes 6.9. Then here 6 is correct now, right? The value is in between this value also in between, right? So the thing is what then? So that means, right, limit method. Limits what we do, just we move in our independent variables value into the particular value, right? When we move into our independent value to the dependent value, move into our independent variables value in particular value, and also our dependent variables value move to the particular value likewise. Okay, so then it has a value. Okay, so that's why we say limit. Limit is describe that one. Okay, therefore then we can finally say when x moving to or x approaching to the 3, our function's value equal to 6. It's okay, correct, right? But this one we explain through the limits method, right? Through describing limits, right? So then otherwise it is undefined value, just only substitute, right? So then sometime we can get it, right? So now I will show you another thing, right? This is another important part, the functions, continuous functions. Okay. So then when function can be described as a continuous, if it can be sketched without lifting your pen from the paper. That means when we draw in the function, if I can draw a function this way, if this is the function, it's a continuous function. When I draw this way, it's a continuous function. But if I draw my function this way, right, just draw in this one, and next my function is start here likewise. That means here in the space, right, in between there is a space. Therefore, this is not the continuous function, right? This is not the continuous function. So you can see in here in my slide, I have given 1, 2, 3, 4, 5 functions, right? When we consider in the function A, first one, this function A, you can see, right, a straight line, right? This function I can draw, right, sketch without lifting my pen, right? Starting point to the ending point. So this is the continuous function. But look at the B function, B graph, right? B graph also show the another function, but when we draw in this one and you stop and again starting in here, that means this is there is space in middle. That means this is not the continuous function. So therefore we can say it is the discontinuous function. And also y is continuous function, right? Sorry, not the y, c, no? C, graph C is also the continuous function because its shape is little bit different, but it's continuous, right? But D is not continuous function, right? That means discontinuous function. Also E is the discontinuous function. If the why? Because if this graph C, if the graph C present the one function this way, right? Eka function එක නම් මෙහෙම පෙන්නන්නේ මේක ඇවිල්ලා discontinuous function එක, right? So then therefore we can say if any value is not in the domain, right, domain of the function, then the function is not defined at that point, and we can state that function is discontinuous at the point x, right? So no domain value, right? Domain එකක් නැහැ. එතකොට අපි කියනවා ඒකට discontinuous function එකක් කියලා. And if the function, right, as an example, if the function fx equal to x squared, right, so whether if this function is continuous or not, so we can exactly say the continuous for all finite values of x, because when x move into the any value, right, any value, x squared function has some value, okay? So and further when we draw in this one, this same function, you can see, right, the shape is this way, right? So all the x value has y value, right? All the x has y value. So then we can say right, any x value has y value, all the x value has y value. හැම xටම y එකක් තියෙනවා. හැම xටම y value එකක් තියෙනවා. Okay? So therefore this is the continuous function, right? And next, one more example in here, right? So you can see the function is 1 over x, right? When we check in or substituting the different value in that function, so when we substitute the minus 2 as x, then it become, or it get the minus half, and if it is minus 1, also the function independent variable value will equal to the dependent one. But when x equal to 0, undefined, right? Undefined, no value, right? So then through that we can test whether this one is continuous or discontinuous function. Right? If it is discontinuous function, then there is no value. But it is continuous function, then we have to say there is a value. So that value we have to understand through the limits, right? So in this case, we know the when we draw in the function, this goes this way, right? Same function with the different ways, two sides. So therefore, this is discontinuous function, right? And then evaluating limits analytically, right? Analytically. Because sometimes looking at the graph is not possible. So graph is not possible to understand whether it has a limit or what is the limit, right? So you need to have other ways to find the limit. So we can evaluate limits analytically using algebraic techniques, right? There are 3 main algebraic techniques. One is substitution method, second one is factorization method, third, rationalizing the numerator or denominator. We call that method is conjugates methods, right? Look at one by one. So first substitution method. Substitution method. So this is the one example. So I have given here the functions. The function is x squared minus 4x plus 9. And my question is evaluate. We need to evaluate that limit. What is the limit? When x move into 2, what is the value of this function? So just we can apply your substitutes. This 2, value 2, x equal to 2 in the function. Right? When we apply this here, x equal to 2, then xx 4 වෙනවා. හරිනේ, x squared 4 and 4 multiplied by again 2, that part is minus, and again minus 9, that is the constant value of our given function. So then value is 4, here minus 8, here plus 9 plus 4, all together plus value are 13, minus value are 8. Therefore the final answer is plus 5. That means we have value. So therefore finally we can say the limit of this function as x approaches 2 is 5. It's okay, right? So then it's okay. So then in this section, right? So factorizing method, that means another example. So in this case, we need to identify the limits of this given function when x move into the minus 1. When x move into the minus 1. So just without thinking about the factors or factorizing method, or just we can apply, substitute, right? So then check, when we substitute in this value here, x squared equal to minus 1 multiplied by minus 1 plus 1, no? Yes, just I'll write in here 1, right? So then this one 1, okay? And 3 multiplied by minus 1, minus 3 multiplied by minus 3, then plus 4. And remaining constant value in here 1, okay? And other side minus 1 plus 1, right? Plus 1. So then simplifying this one, it's become 0. Other side also becomes 0. 0 divided by 0, indeterminate, right? No value, right? So that means if we tried using substitution, the result would be 0 divided by 0. That means the technical term for the result of 0 divided by 0 is undefined, indeterminate, right? Which means that we cannot determine the limit using this method. Okay. So what can we do, right? Just we can move to the, think about the next method that we can apply, that is factors, right? Factorization method. So we can check whether there are factors in this, whether are there any factors for this given function, right? So the function, so this one, shall I write it? Function is, because I want to move to the empty slide, right? Just I will write it in here. This is the one part of my function, right? And I write other x plus 1. Then shall I move to the empty slide? So you can see, right? So then I can check, right? Are there any factors? So you know this is the quadratic function, right? Quadratic function, right? So then we know if there are only 3 terms, right? So we know how to then factorize this one. Just we have to consider the constant term, that is 4, and we need to check what are the factors for that. 4 into 1, next 2 into 2, no? And then considering the all factors, we can check whether when adding no minus in these factors value, can we get the middle terms coefficient. In this case, middle terms coefficient is 3, no? Right? So when we consider in this one, if we add, it becomes 4, not equal to this. When we minus in this one, no, But when we consider in this other factor, when we add in, it becomes 5, but when we minus in one from other one, it's okay, it's equal to 3. So then I want to select this factor. By selecting this factor, we have to write our middle term. Okay, so then our functions terms are x squared, right? I'll put in here. So 3x I can write by 4, yes, not the 3, with the 4, no? 4x plus x, right? Now I want to think a little bit, because our original function has a minus 3. So then the biggest one should be minus and other one should be plus. That means I used two factors. The values in my factor, right? Two values, 4 and 1. 4 and 1. Okay. But the thing is, by using this one, I want to write it as the equal with the original function's middle term. It's now okay. Minus 4, 1 plus x. This become minus 3. Then 4. Then I can write what we call the factors. No, we can write factors when considering 2. In here, when I'm removing the x, that is x is the common for these two terms. X minus 4 remaining. For this one, there is no common value. Then we can consider 1 is common for those two. Then remaining is this one, right? So then these are the two factors for the given function, right? X plus 1, right? Is equal. So now I can delete these things and I write it in here, right? Okay. X minus 4, no? One factor, other factor is x plus 1. And in here also x plus 1, right? Now you can see this is our function in the middle, right? That means in between the two brackets, meaning is multiplication, product. So therefore, when we simplify further this one, we can cancel these two together, all right? So then finally it remaining is this value, right? Now we can check, because what is the value they set? Minus 1, no? Yes, minus 1, right? Limit. So in this case, we need to find limit when x move into minus 1, right? In here, when x move into minus 1 limit, right? So now we can apply here minus 1, then minus 1, minus 4, altogether minus 5. Now we got the value. Okay, we got the value for this section. That is in this functions, when x move into minus 1, our function's value equal to minus 5. We got that, right? So then that is the second method we can apply to find out the limits, right? And then I will move to the another one. Yes, this is another it is another function, right? Another function, complex function. So we can see, right? Just right, we need to find out this function's value when x move to the particular value, that is 7, right? So no need to look at all these things, right? Just think, just considering this 7, right? You can see just when you apply in this 7 here, what has happened? This part becomes the 0, right? That means no meaning again. It becomes meaningless one. So that means substitution method is not appropriate for this one, right? So then we can check whether is there any factor? Are there any factors for this function, right? So it's all right. No, we can't find out factors for this one. So then we need to think about another method, right? Because just we think when checking this one, this is not the discontinuous function. This is the continuous function. So it should as a value when moving to the any value moving to the its independent value moving to the any value, it should as a value. Function should as a value, right? So therefore, then we need to try to take the value for this one, right? So it is impossible to apply substitution method, and also it is impossible to apply factorizing method. Now how we can do that, right? So I'll write our function, right? What we want to limit x move to 7 and x minus 3 square root of that, then minus 2 and x minus 7, right? So this is my function. So then the method is, right, basic mathematics, right? According to the basic mathematics operations, we know if we have any equation, when we doing anything for the same thing, right? Same thing for the both side of the function, original function not change. That means if our function is x equal y, then we add in 2 for the both side, x plus 2, then also should be equal to the y plus 2. Similar to that one, if we have any kind of function, when we doing this kind of quotient function, bedimak sahita, when we multiply this same thing by 1, right? 1 by it's not change. That means I'll put this, if this is the function, when we multiply this one, 5, 5. That means 1. 5 divided by 5 means 1. So I just multiply this my function only 1. It's not change. Not the change original function. Right? So same time when I multiply this one, it's okay. Why? 5x divided by 5x here, that means 1. Right? This part I multiply by 5x, this part also multiply by 5. So similar method we have to apply here. Oh my God, no, my function is missing here. Give me 1 second just. Right? So, then what I want to do here, just I want to remove this x minus 7, right? Otherwise we can't get the value for this one, because if until it is here, right, x minus 7, this whole part becomes 0. So therefore in this case, we can multiply this one same value like this. Okay, that means the x minus 3 square root plus 2, right? Because I need to cancel or remove middle term of this one, right? So then same one. Okay, so then original function is not changed when I multiply in both sides like this way, because this whole part become 1, right? Whole part become 1. So now I will do another place, and just we need to multiply by first square root x minus 3 minus 2 multiplied by x minus 3 plus 2, right? So I will show you in another place to you, right? This mathematics, right? In here you can see I have applied more basic mathematics, algebra rules, conditions, right? So you have to know all these things, right? X minus 3 is the one bracket, other bracket is, right? Now first I want to say, when we multiply in this one, right? Minus is, sorry, 2 square root multiplying by 2 square root, what is the value? It's become 2. We can remove the square root. Am I correct? When that means x square root x multiplying by x square root, that means x, right? So you can understand when I put in here 4, 4, then you know what? Because square root of 4 is 2. A square root 4 is again 2. 2 multiplied by 2, 4. Okay, so that is the rule I apply here, right? So then you know if I have two brackets, when I want to remove those brackets, I want to multiply by this first term, right? First term with the second bracket first term. That is my first term. And second term we can get when multiplying the first brackets first term with the second bracket first term. And when I want a plus for that second terms, when multiplying second term with first term and with multiplying the first bracket second term with the second bracket second term. Sorry, very sorry. Second terms first, second bracket first term. Okay. සාමාන්‍යයෙන් මෙහෙම කියනවනේ නේද? මෙහෙම අපිට ආවොත් බ්‍රැකට් දෙකක් ආවොත් මේක සුළු කරනකොට so when we අපි ඉස්සෙල්ලා මේ දෙක එකතු කර වැඩි කරලා ලියනවා ඊළඟට මැද පදේ ගන්න මේ දෙක ළඟ දෙක වැඩි කරනවා ඈත දෙක එකට වැඩි කරනවා ඒ දෙක එකතුව තමයි මැද පදේ ඊට පස්සේ අවසාන පදේ ගන්න බ්‍රැකට් දෙකේම අවසාන පද දෙක වැඩි කරලා so same thing we can apply in here so you can see then our first bracket become x minus 3 when I remove in the square root because square root දෙකක් එක්ක එකම අගේ වැඩි කරාම square root එක අයින් වෙනවා. This is the first part. Second term I can get when multiplying the minus 2 square root minus 3. And I need to add this one to what? Other one. That means plus 2 multiplied by x minus 3. Right? That is the two terms. ඒ කියන්නේ මම මෙන්න මේ පදේ මෙන්න මේ පදේ මේ පදෙන් වැඩි කළා මේ පදේ ඊළඟට මේ පදෙන් වැඩි කළා. So then say again the similar two terms. One term is minus, other terms is plus. ඒක නිකන් මේ වගේ ධන එකයි ඍණ එකයි වගේ. ධන x උයි ඍණ x උයි වගේ. Right? So okay, that mean again it's become 0. Right? Here you know 0, no? This one also 0, right? That means middle term is already cancelled. I'll write in here, then you can see it and you can understand, right? When x move to the 7, this part, first one, x minus 3. Middle term is already cancelled, right? And the finally, third constant term is minus plus become minus 2 into 2, 4. Right? මම උඩ පැත්ත කරලා ඉවරයි. මොකද්ද කරලා ඉවර? Simplify. Now I can write in the other part. That is, then I can complete numerator and denominator both. Okay. Here x minus 3 plus another one. First I want to write this one. Original function's value x minus 7. It is in here and further it has x minus 3. Yes, no need to write in here. Just that's enough. Plus 2. Okay. Now check. When we applying x minus 7, what has happened in upper side? So before that, we can do this one, right? We can simplify this further. What is then value? X minus 7. We have one bracket here, or x minus 1. In here, you can see both values, right? I am not going to waste time. Just think this part is in here, right? So now you can see. Oh, anyway, I go to the this. In here, this one, right? So now we can simplify this one further, right? We can simplify this one further. You can see we can cancel these two together, right? When we cancel in this one together, we can put in here 1 because you know when we divide in x1 by x, answer is 1. When we divide in 2 by 2, answer is 1. Right? Same thing in here we did. Okay, so therefore, this now remaining part is, I'll write in here 1 divided by, right, a square root x minus 3, x minus 3 square root of x minus plus 2. Just now check, can we apply x move to the 7? Yes. Now when we apply in here 7 instead of x, square root 7 minus 3 plus 2. Right, we can further simplify, no? 2. 1 over, when deducting 3 by the 7, it becomes 4 by, there is a square root, plus 2. Okay, then we know square root plus square root of 4 means 2. Then finally you can say 2 plus. We got the answer. Okay, we got the answer value, right? But the thing is, we use the method that is not the substituting method, that is not the factorizing method, that is the conjugate. We call that method is conjugates method, right? So then here you can see, right, if our function is continuous function, then there should be a values for the function if independent variable, when independent variable move into the any particular value. So that is the way how we can compute those values, right? So then next, yes, in here, yes, the next part is difference. I hope to discuss with you the differentiation rule, but I think we in this session, right? So our session is limited to the 1 hour, so we have no time to discuss second one, next part. So I think we can discuss, right? We can discuss this part, right? This remaining part in our next session, that is also under the calculus, second branch of calculus, differentiation, right? So I will discuss from this point, right, in my next session, right? So then we have come to end of this session, and I am stopping this session now, right? So thank you very much.